Hi, this is Module 5, Video 34. In this video, we're going to write our exercise parser. So just to explain which part of the exercise document we're going to be parsing in this video, basically everything from this level 2 title down to the next level 2 title, which is here. So everything highlighted here represents a single exercise, and similarly, here's another example with the push-ups. And the parts of the exercise are the name, which is the level 2 title. And then the first thing we expect in our list here is the set and rep count. And following that, we've got any number of matches with their actions. So you can think of this as the matcher and then this as the action. And similarly, this is a matcher and this is an action. In this case, it's a sequence action with various child actions in there. So that is what we'll be parsing. It's not going to be as complicated as the numerical constraint parser, but still not entirely trivial. So let me create the classes we need. Okay, so this is the public API we're shooting for. We're getting a parser that gives us back our exercise model instance. And of course we need to take all our services, or all the relevant services here, because an exercise is comprised of all the bits and pieces that we've built up until now. So we know that we're going to need all those services. Now I'm going to break the tests up just like I did with the previous video. I'm going to break them up per the different pieces of the exercise that we need to parse. So for example, we'll have a set of tests for the name, a set of tests for the set and rep count, etc. So I will write each one and then explain it as I go. Okay, so here's my first test. We're just checking that we can parse valid names, or can parse names in the input. So I'm using the parser and then parsing the input and then making sure that the result, which is an exercise object, is not null, and then making sure we get the expected name from the exercise's name property. And here are my test cases. Starting with the simple cases, making sure that we are case sensitive, and then a bit more complicated case where we've got 2 words, and then some white space around the name, which I just want to discard and just grab this part of the name. One thing to point out here is I think our test will break later once we add, as we progressively flesh out our exercise parser. This test will break because we don't have the set and rep counts in here or anything like that, unless we make that optional. I don't know yet. So that's the first test. So now let me write a test around the set and rep counts. Okay, here we go. So the test code is pretty much the same, except our assertions are against the set count and repetition count instead. And the test cases, the first one here, 3 sets by 10 reps. Obviously we're expecting 3 and 10, but here we've just got the kind of degenerative case where you've got 1 set and 1 rep. And then here I'm making sure that we can parse either plural or singular form of both, and it's pretty lenient here. I mean, technically, to be grammatically correct, this should be sets, but we're allowing set, and here to be grammatically correct, it should be rep, but we're allowing reps. So that is that, and then the next test is around the matches with their actions. Okay, so here's the final test that we'll be writing as part of this video anyway. This is a test to make sure that we can parse out the matches with their actions. Now it may seem a little bit limited here that all we're doing is asserting that the matches with actions in the result have the same matcher type as some expected sequence of matcher types. But the fact is we've kind of already tested the parsing of matches and actions, action lists, that kind of thing, separately to this fixture. So this is really just about making sure that the exercise gets populated with the data from those other parsers. So the test cases are basically you can ignore everything up until this point. So we've got a before matcher here, and then the action is irrelevant. I just want to make sure there's an action in there so that the parsing is successful. And in this case, because it's non-discriminatory, we just expect it to be a typed event matcher, and it should be a before exercise event. And I will add another simple case for after, like that. And then the next case we've got is before set. So it's the same deal, except this time we're before a set. So the event type should be before set event. And then we've got another matcher here, this time before rep. So we expect a typed event matcher with before repetition event as the generic type argument. And then next we've got before set 1, so that should be a numbered event matcher for the before set event. And similarly we've got before reps 1 to 3, again that should be a numbered event matcher, and before repetition event. So those are our tests. Let's just make sure that builds and the tests fail. Cool, that's all failing, so let's start on the implementation. And again, I'm going to break it up into distinct private parsers for each of the components that we care about, and then kind of compose them together in this public parser here. So we'll do this stage by stage again. So we'll start with a parser for the name, and then get progressively more complex from there. Okay, so the name parser, yep, that should be read only. The name parser just parses out the two hash symbols, followed by the name, which is basically any character until we reach a new line, surrounded by white space. I'm not entirely sure this expression is going to work with trailing white space, but I guess we'll find that out. And then it converts that to a string. So all I'm doing from this public parser at the moment is grabbing a name and then creating an exercise based on that with no reps, no sets, and no matches with actions. I did forget some tests around checking that these arguments are not null, so I'll quickly add them. And of course, in order to pass those particular tests, I need to add some checks here. Okay, so now we can try our tests again. Except that we are not building because I forgot to rename these. As I was worried about, the parsing isn't quite correct with respect to trailing white space. It's stripping out the leading white space, but it's a bit difficult to strip out the trailing stuff. Because we've got this until here, that means it's going to grab everything until it reaches the new line. So it might be better just to parse everything and then trim it. So just go like this. Okay, cool. So now we are parsing as we had hoped. The name, that is. So the next test is around the set and rep counts. So let's write the code for that. Okay, so this is a little bit ugly here, but so I'm parsing out the leading asterisk, and then the set count is basically a number which we then convert to an integer, and I've tokenized it on any white space apart from a new line. And then following that, we want set with an optional s after it, again tokenized with anything other than new line. And then we've got this x, which can be uppercase or lowercase. I've added another test case here because I forgot to check case insensitivity around sets and reps, and this x here. And then we've got the same thing for repetition count, and then I'm converting that into a tuple with the set count as the first item and the repetition count as the second. So now I've changed our main parser here to use the set and repetition count parser and extract the information to pass through to the exercise. Now I do expect this to break our name tests because we don't have any, well, unless we make this optional, unless we make this entire parse here optional, in which case we'd have to check that whether it's matched, and if not, then the set and rep count would be 0. And you would end up with an exercise that is completely useless. And I think that's probably more dangerous than just requiring it to be there, because then, once we get to the UI level, if you've left out the set and rep count, then it won't parse the document and it will give you an error saying something to that effect, instead of you getting an exercise back with 0 reps and 0 sets and wondering why it doesn't do anything. So I'm going to leave that in. I'm going to expect these tests to fail here, and then I'll fix them, and hopefully these tests will pass though. Okay, yep. It can't parse the name anymore, but it is parsing the set rep count as we hoped. So let me just fix these tests up. Okay, cool. So now we're passing everything apart from this last matches with actions test. So let's have a look at how we're going to do that. Okay, so here's the basic gist. This is a little bit complicated, but it's been broken down into fairly small chunks, so each one is pretty understandable. So first of all, we've got this parser which gets us a matcher with action, and specifically a matcher with action where the matcher is a typed event matcher. So I've called it get typed event matcher with action parser. And obviously it takes all the arguments, but it takes all the services, but it also takes its name so that it knows in the document what this particular typed event matcher is signified by. So for example, before would signify the before exercise event, before set would signify the before set event, etc. So what it's doing is it's parsing out the leading asterisk and then any amount of white space and then the name followed by a colon. So for example, that there is where we're up to so far, assuming the name is before, and then it passes out the actions as an action list. And actually I don't think that's going to work because we've not got a new line in here. So now it'll get the new line, then it will start parsing out the actions using our action list parser. And I've used level 1 here because so that we need this indentation here. Okay, and then I create a sequence action based on those actions because our match with action can only take one action. So I just stick all those actions into a sequence. And so based on that action, I can create the new match with action. I can create the typed event matcher, and I know the type is type T because that gets passed in as a generic type parameter, and then I can assign the action to that. Now slightly more complicated is the get numbered event matcher with action parser. Again, we're taking the type T here of the event, but this time I've constrained it to the numbered event as a base class. And again, we're taking the name, but this time we parse the name on its own, and then we parse at least some white space. And then we use our numerical constraint parser to parse whatever numerical constraint is present. And then we look for a colon, and then again, I think I've missed the new line here. Like that, and then we do the same thing with the actions and put it into a sequence action, and this time we're creating a numbered event matcher. And this is the only real tricky part here, is we are using our numerical constraint, which is a function that takes the execution context and returns a boolean if that if it matches. But this numbered event matcher takes a function that gets a T, which is the event, and returns a boolean. So basically I have to turn that event into an execution context, which is easy because events have an execution context property. So I'm just dereferencing that and passing it through to our other function. And the only other tricky aspect to this is that this method also takes the get actual, get first, get last functions, which will pick out the bits from the execution context that are relevant for that event. So for example, the before set event, it would get the set number for this function, it would return number 1 for this, and it would return the set count for that. So those are the main building blocks, and then I've got this get matcher with action parser, which returns a single match with action, and it's going to use these two methods to kind of compose together the entire set of discriminators that we support. So I've only got 2 here at the moment. I'm going to flesh this out shortly. So you can imagine before set, before rep, all typed first, and then I will do the numerical equivalent as well, so that if this one doesn't match the typed one, then it will try the numbered one. Okay, and then to top that off, we've got this get matches with action parser, which is basically the many version of this, so it returns an enumerable of that, and all it does is use that building block and delimits it by a new line. That's about it for that, but I did miss some tests as well. We want to make sure that this is case insensitive, so I will add a test for that. And the other test we'll eventually want is one test case here per each of these calls. So I think I'll add those test cases now so we can see them failing. Okay, so those are all the cases I can think of. Before, after, before set, after set, before rep, rep. Actually, that should be during. After rep, before set, after set, before rep, during. I don't know whether I should make this during or during rep. Probably during rep, just to be more consistent. So those are all the typed event matches, and then we've got the numbered event matches. So I've just stuck a number after each of those. Obviously, there's no numbered version, no numbered equivalent of the before and after exercise, because that doesn't make sense. Right, so let's just see some failing tests and then flesh out the implementation. Okay, so it's failing all of those. So first things first, I can add a call to the parser from here. Hopefully that's enough to get some of the test passing. No, it's not, and it's actually caused further failures. So I can't even parse a name anymore because, again, the matches with actions is required and probably should be, because otherwise you've got an empty exercise program. But to be honest, I think that's harder to miss because, I mean, you're going to see it that you've not got any, you've not got any instructions basically for your exercise, whereas it'd be easy to miss the set and rep count. So I'm going to make that optional. There we go. So get or else is basically get or default with a default value. So if it's not defined, then we're defaulting to an empty match with action collection. So that should get us back to where we were. It has. So the question is, why are none of these at all passing? I was expecting this one to pass and this one to pass. Hey, I'm just back from debugging that problem. Turns out I was just missing the for here, so I had wait 1 second instead of wait for 1 second. So I've gone through and fixed all those. But I also wanted to point it out that during the debugging process I wrote this helper method here, which just allows you to execute an action when a parser matches. So I've got a then continuation on the parser, and then I execute the action with the result of that parser, and then I just return that same result again. And I use that in various points throughout the parsing process just to see where it was getting up to, because one thing Sprash is pretty poor at, to be honest, is telling you the exact point in the input where it stopped or where it failed to match any further. Because what it does is it rolls back to the point where it last successfully matched, but it doesn't tell you how far in past that point they'd actually successfully matched. And in this case, it was matching this, it was matching the white space, it was matching the name, it was matching the new line, but then it was failing inside this action list parser. And here's an example, by the way, of the output of the using that utility method. So I've just got .do and then some diagnostic output. And I wasn't seeing that, I was seeing it up until this point. So I knew that it was the action list parser that was failing to match. So I knew where to look for, what to look for in the test case. So I found that, fixed that. Now let's rerun our tests. So now we are getting the two successes that I kind of expected to see with the before and after discriminators. So now what I can do is flesh out the rest of the discriminators here and see how we go with the other tests. So let me do that. So that's all the typed event matches. So I'm going to try the test again with these before we get to the numbered event matcher. So we can see here quite a few more are passing. And the ones that aren't passing are the numbered ones. So now we can add support for the numbered event matches, which is a little bit more complicated. Okay, so here you can see what I've done. It's a little bit hard to fit this all, or to format this so that you can actually see it all. But we're calling our getNumbered event matcher with action parser, passing in the event that's relevant, and passing in the name that we expect to see, or the discriminator that we expect to see, before the numerical constraint. Then passing in the services as per usual, and then we are passing the three functions that we need to get the required information from the execution context. So in this case, to get the actual, we're dereferencing the current set in the execution context. First is always just going to return 1, and for the last, we dereference the current exercise and the number of sets in that exercise. And similarly for repetition events, we use current repetition and the repetition count in the current exercise. So let's see how that goes with the tests. Okay, I've missed a couple of 4s in here. That's one of the problems at least. And another problem I just thought of is that here I've got plural reps, whereas in the parser here I've only accommodated singular, which is a bit of a pain because they aren't always, it's not a case of just sticking an optional S on the end, because some of these we don't want to have an optional S on the end. I mean, we could change the name parameter to be a parser, which parses the name, but that's probably more complicated than just adding another Boolean argument that says whether the S is allowed or not on the end. So let me do that for now. Okay, so I've added this name can be pluralized argument to both these methods, and if it's true, then after the name, then we parse an optional, sorry, this should be optional. Parse an optional S, ignoring the case. Otherwise, yeah, we don't attempt to parse the S at all. And then, of course, I've passed through the appropriate values here. Only these two cannot be pluralized, so everything else is passing through true. So let's try that. Okay, I've got the wrong type here. So I think for starters I should redo this a bit so it's a bit more readable. So the problem here is that this optional is returning a parser of I option of I enumerable char. And when we are not, if we can't be pluralized, we need to return something. We need to return a parser that just matches on anything. What I really want here is a method on parse that just, I don't know what you'd call it, maybe default, which you can give a type, you know, optional of whatever, and it just gives you back a parser that always succeeds or doesn't really do anything other than give you the right type. But I cannot see anything that does that. Okay, so nothing like I just described exists. I've just written it. I've got this parseExt class which has this default method, and all it does is return a successful result with the default instance of t, whatever t might be, and then the same input that it was given, so it doesn't consume any input. It's almost like just a type conversion, and then I'm using that here just to get a default instance of I option of I enumerable char. And of course I've made those same formatting changes or refactoring changes to this method as well, as you can see. So let's try the test with that. Okay, getting closer. Let's have a look at what's failed here. Just set a breakpoint on this to try and see where it's going wrong. So this is the test case that looks like it's failing. Annoyingly, it's really difficult to see into this immutable list. So the action in the sequence action, the matcher is a numbered event matcher of before repetition. What are we expecting? Numbered event matcher of after repetition. Okay, so I've got the wrong. No, I'm looking at the wrong test case here. After rep 1. Even though we're specifying after rep 1, somehow I've ended up with a before rep event. I wonder whether I've done something wrong here. After repetition. Yep. Copy and paste error. I did not update these. So that would account for the 2 failing tests, hopefully. Hooray! My God, that was definitely a bit hairier than I expected. And I know this code could be a bit cleaner, perhaps by separating out some of these common, parsers like the name and what have you into separate parsers. But that is it for our exercise parser for now. I will see you in the next video. Bye.